In this tutorial, we're going to talk about section 3.3, about increasing and decreasing functions, and then at the end we're going to talk about the first derivative test and what it does and why we use it. So, increasing and decreasing functions. Let's first take a look at your textbook, and this is on page 179. I'm writing it up in the corner in case you want to go look. But this is a lot of definitions, and I want to make sure that the picture is here with it. So I first want to draw your attention to this first box. And it says, it talks about the definitions of increasing and decreasing. So a function f is increasing on an interval if for any two numbers, x1 and x2, in a particular interval, x1 being less than x2, implies that the functions of those two are also the same. So, in other words, let's take a look at our picture. If I pick this point in red, and I pick this point here in blue, that means that this is x2, and this is x1. So let's make sure that it fits all of these definitions. So, first of all, does it fit this part here where it says x1 is less than x2? And the answer is yes, x1 is less than x2. So it implies that f of this value, so f of x1 is less than that of f of x2, and that means the y values. So is the y value here less than the y value here? And yes, of course it is. So if I can pick any 2 points on a function and this be true, then this is an increasing function. Or at least it is on this interval. Okay? Alrighty, so let's take a look at what decreasing is. So we're going to pick 2 points again. I'm going to pick up some points over here. So x1 is going to be here, and x2 is going to be here, because I have to make sure that the first premise is met, which says x1 is less than x2. And you know what? I've got that backwards. Let's fix that real quick. Because in this case, x1 is actually greater than x2, so we need to switch these guys up. This is going to be x1, and this is going to be x2. Alright, so the way that this implies this information, it looks a little bit different. Look at the inequality sign. Okay, so f of x1, which is here, the y value here, is greater than the value here of y. And is that true? The answer is yes, it is. So that is what is considered to be a decreasing function. Alright, so this is all great and dandy. Let's take a look at the second part, this box right down here. So we want to test for an increasing or decreasing function. So if ever you're concerned or you're not sure whether to tell it's a decreasing or increasing function, this box right here will tell you everything that you need to know. So first of all, it says let f be a function that is continuous, okay, on a closed interval and differentiable on that interval. Okay, it does not have to include the endpoints. That's what it says. Okay, so number one, if f prime of x is greater than 0, well, keep in mind that that means that the slope is positive. Okay, so the slope is positive. For all x's in that interval, then f is increasing on that interval. So at that particular point, if that slope is positive, and it's positive for every single x in a particular interval, then it's increasing. The next one says if f prime of 0, or if f prime of x is less than 0, so that means all my slopes are negative. For all of my x's in that interval, then f is decreasing. If it happens to be the odd ball and be equal to 0, we should know that that's a maximum or a minimum of some kind, or that it could be a possibility that it's constant. And the difference is that the derivative equals 0 is not just for one point in particular, but for all x in that interval. So if it's an increasing function, all the slopes are positive. If it's a decreasing function, all the slopes are negative. And if it's a constant function, that means the slope is 0. So let's take a look at this example. And this is figure, let me see if I can write this down for you. This is figure 3.16, and it is on page 180 if you're interested in looking at the actual picture. But what I'd like you to do in this problem is we want to know the intervals on which f is increasing or decreasing. And I really like using colors for this. So I'm going to denote the increasing parts of this function in blue and the decreasing parts in red. And I'm going to use my definitions that I just learned to help me out here. So I'm going to go ahead and find the increasing parts first, and that's where all of my slopes are positive. And I like to just kind of estimate what I think that they'll be. So let's take a point on the left-hand side here, this point here, let's say. And I want you to think of your tangent line. Okay, you can even put a pencil up to the screen and create that tangent line if you'd like to. And is it going to be a positive slope or a negative slope? And the answer is that it's going to be positive. So let's pick another point farther to the right. How about this point here? Does that have a positive or negative slope? And the answer is that it's still positive. In fact, this is positive all the way up to this point right here. So I'm going to highlight this entire part of the line in blue. Okay, so that's one of my increasing intervals. Let's take a look at the places in between this maximum at 0, 0 and the minimum at 1, negative 1/2. So if I were to pick a point, let's say, right here, and if I were to tell you if that's a positive or a negative slope, that sure is not positive any longer. So this part between the maximum and the minimum, it's not going to be an increasing part of my function, so I'm just going to get rid of that. Let's continue to a part farther to the right of that minimum. How about this point right here? And that's also a positive slope. If I were to pick another point up here, also positive, and positive for the rest of the way. So I'm going to highlight this in blue, and let's go ahead and see if we can write our interval notation. So over here where it's increasing, I'm going to start from the left and work my way to the right. So this goes from negative infinity, of course it doesn't touch it, and it goes all the way up to 0. But we want to make sure that we know that 0 is not being included in this, because at 0, since that's a maximum, my derivative is 0. My slope is 0, so I can't include that point. And I'm going to use my union here, and let's continue with the next part. So this is going to be from 1, not including it because the slope there is 0, all the way up to positive infinity. So then the negative portion of this is this right here, because all of my slopes all the way through here are negative. So for the decreasing part, this is going to be from 0 to 1, non-inclusive. So this is how we can tell whether our function is increasing or decreasing. So we can take a look at another problem if you want to. So in this problem, this is our function, f of x equals 1 over x. And if I want to know where this function is increasing or decreasing, let's go ahead and start with increasing. You can start with whichever one that you want to. I'm going to start from the very left-hand side of this function, which is here. And with consideration, actually, you know what, let's pick a different point. Let's pick this one right here, because my picture is not all the way accurate since I'm freehanding this. But here at this point, my slope is positive. And if I keep on going farther and farther to the right, my slope just actually gets more positive. And I want to let you know that if I pick points over here, that these are also increasing, although my picture doesn't make it look so much like it is. So this whole portion is all increasing. So what about this other branch? Well, if I pick this point here, that's a positive slope. In fact, it's extremely steep. And then over here, that's also a positive slope, and here it's also positive. So this whole branch is also going to be positive as well. So there are no decreasing parts of this function. But I do have an asymptote at x equals 0, so I can include that in my intervals. So this is increasing from negative infinity all the way up to 0, non-inclusive, and then from 0 to positive infinity. So that's how we're going to work those kinds of problems out. So here in your textbook on page 181 is the definition of the first derivative test. So at this point in time, we know what increasing and decreasing means, and it's useful in determining our critical numbers, our maximums and minimums. So number 1 here says that if f prime of x changes from negative to positive, in other words, this first picture here is what it's talking about. So my slope goes from negatives, and let me stick with my colors. It goes from negatives to positives, then the number that I'm being concerned about has a relative minimum at this point. So that's a relative minimum, as long as it goes from a negative slope to a positive slope. The second one here says if f prime changes from positive to negative. Well, that's talking about this guy here. So positive to negative, then my value is a relative maximum. And then these bottom two pictures say that if I have positive and positive, then the point that I'm talking about is neither a maximum nor minimum. And the same thing goes with negative. If this is negative and this is negative, this guy's just a nothing. So those are ways in telling if you have increasing and decreasing parts of your function, if you have maximum and minimums. So let's actually use this first derivative test in helping us determine maximums and minimums throughout an interval. Alright, so let's use this first derivative test to help us find relative extrema of this particular function. So the first thing that we want to do is we want to determine, and hang on one second, I'm going to write that at the very top so that you know why we're doing this. We first of all want to find where f prime of x is equal to 0. So let's go ahead and differentiate this function. So f prime of x is going to equal 3x squared plus 4x. And let's set that equal to 0. I'm going to factor out an x here. So x and then 3x plus 4. So one of my solutions is going to be x equals 0. And then we're going to solve this piece right here for 0. Let me do this over here. So subtract 4 from both sides. And that gives me 3x equals negative 4. So x equals negative 4/3 is another value. So here's what we're going to do to use our first derivative test. So the second thing is set up your test. And this is how I do it. If you think that you can find a better way of doing this, or if you see another way of doing this on the internet or YouTube, by all means please use it. But I like to set up a number line, and by placing my zeros, my values that I just found in numeric order, so negative 4/3 would be to the left of 0, and I'm going to pick values farther to the left and farther to the right, any number that I want. So a number out here, let's pick -5, just cause. And over to the right, let's pick 3, okay? Now the reason why we're doing this is we're trying to figure out what's happening between all of these intervals. Are they increasing? Are they decreasing? What is happening? So over here, in between these two guys here, okay, we want to pick a value somewhere in between and plug it in to our function to see what's happening. And I'm going to be plugging these values into my derivative function because I want to know what's happening to the slopes, and derivative means slope. So I'm going to go ahead and I'm going to plug in f of, I don't know, let's say -4. And this is, of course, into the derivative function. And when I do that, I get positive 32. So within this interval, all of my slopes are increasing. So what about in this interval? Well, -4/3 is a little bit more than -1, so let's pick -1. So f prime of -1. And that gives me -1. So in between these two, this is decreasing. And then in between 0 and 3, let's just pick +1. You can pick any value that you want in between those two numbers, and I happen to get +7. So because of this test and knowing what the definition of increasing and decreasing means, I can tell you that this value here, x equals 0, is a maximum, and that -4/3 is a minimum. And these are, of course, relative because I do not have a defined interval. This is over the entire thing. And that's how we use the first derivative test to help us find relative extrema of functions. And that's going to conclude this tutorial.